We're here to talk to you about
Thorium reactors!
thorium is an alternative nuclear fuel source to uranium, and we're here to tell you why it is superior.
So we have two options for nuclear fission reactors. We have U-238, which needs to be transformed to plutonium-239 before it can be used as a fuel. Thorium needs to be transformed to U-233 before use. So you need 2 neutrons per reaction. One to transform thorium-232 to U-233, and one to cause the fission. U-233 produced from thorium is unsuitable for weapon use because of contamination with U-232. Plutonium is easy to separate from waste and used in bombs. The thorium cycle avoids plutonium entirely. Also, thorium doesn't need to be enriched for use. All these factors give thorium reactors much less potential for proliferation of nuclear weapons.
But how does it work?
Well, Dave, fission heats the salt core of the reactor. This heat is transferred and exchanged in a heat exchanger that turns a turbine, in the same way that light water reactors work. The difference between this, though, and a light water reactor is that a tank of liquid thorium surrounds the reactor, which absorbs radiation. The thorium-232 is transformed into uranium-233 and is fed into the reactor core as fuel.
The problem with plutonium is that it's a major health concern of long-term nuclear waste. It's got a half-life of 24,000 years, which makes this toxic waste very difficult to dispose of. Now, thorium fuel cycles, on the other hand, produce a lot less transuranic waste. In the thorium cycle, uranium-233 has a 90% chance of fission, and the remaining 10% has an 80% chance of fission as uranium-235. This leaves only 2% as transuranic waste. Now, this is 20 times less transuranic waste than light water reactors produce. This means that the thorium fuel cycle allows for much easier reprocessing, and the reactors could be fueled without excess mining. This improved fuel efficiency allows 1 ton of thorium fuel to produce as much energy as 250 tons of natural uranium. That's 4.1 million tons of black coal. This means that thorium reactors produce waste that is both lesser in toxicity and quantity.
The coolant salts remain liquid at very high temperatures. This allows these reactors to have a higher operating temperature. From the equation that we learned in class, this means that T1 is big while keeping T0 the same, which allows for a higher thermodynamic efficiency. Typical lifters operate at 45% thermal efficiency, with future models predicting efficiencies as high as 54%.
In a 2013 report from the Bellona Foundation, an environmental NGO based in Norway, it's found that 1 gigawatt of thorium power plant would cost roughly $780 million to run, whereas a gigawatt for a uranium-fueled reactor would cost $1.1 billion. For thorium reactors, there's less manpower required, and staffing costs only $5 million instead of the $50 million required by uranium reactors. The sheer affordability of thorium reactors would greatly benefit countries that are impoverished or politically unstable, because they would be provided a really great energy source without the fear of promoting nuclear weapon capabilities.
If it's so great, then why aren't we using it?
Well, Soud, back then the US was very heavily focused on funding uranium-fueled reactors because they had far more industrial and political backing. In 1971, Nixon prioritized these reactors on account of their ability to create more jobs and provide plutonium for the Cold War. As a result, competitive alternative fuels like thorium were shut down, and their potential was never revisited. But all is not lost, because today, India is the world's biggest thorium resource and plans to get 30% of its electricity from thorium reactors by 2050. China is developing a next-generation reactor that will enable thorium to be used much more safely than uranium within the next 10 years. And Norway, Thor Energy, is developing technology to use thorium in existing reactors together with uranium or plutonium.
So there's still hope!
Thorium is definitely getting a bigger role in today's world.
We hope you learned a lot from today's presentation.
About why thorium is such a great fuel source. More affordably for countries that are
Pause, here we go.